All right, Bulldogs, how we doing? It is, what day is today? It's Wednesday. The wind is howling. It's 6:10 at night. And woo, that is some wind. And we're going to review a little bit of this elimination, okay? Essentially, I'm trying to eliminate one of these, right? Because if I have x plus y equals 3, I don't know what's what. But if I can eliminate one of these, then I do. So that's essentially what we're doing here. Now, if I look at the 3y's, if I add these together, they're going to cancel each other out. I realize that if I were to subtract them, 3y minus a negative would be a plus, and that would be 6y. We don't want that. So I have to recognize that I'm going to add these. So if I'm adding them, put a big plus sign here, draw my line, and 4x and 5x, I'm going to add, so this is adding. I have a 4x and I have a negative 5x. That'll leave me with a negative x. This cancels. This equals 4. Negative x equals 4. But I don't want negative x, do I? I want regular x. So I'm going to multiply by negative 1 because anything times 1 is itself, and anything times negative 1 is its opposite. So what I do to the left side, do the right side of the equation, and I get x equals 4. Am I done? I'm not done. I'm going to plug this into either this equation or this equation. So what's the point here? The point here is this. If I have a graph, I have two lines here. I've got this 4x plus 3y equals 2 line, and it's, I don't know, let's say it's something like this. And then I've got a negative 5x minus 3y equals 2, maybe something like this. Who knows, right? And this point of intersection means that this is where the lines meet. It basically means that they share a very specific coordinate. So whatever the coordinate is, that means that the x and the y of that coordinate are going to be equal. So it doesn't matter if I plug it into the first equation or the second equation, I'm going to get the same answer. So I have x equals 4. Let's use the first one right here, the 4x plus 3y equals 2. So I'm going to copy and paste this. Copy, paste. I'm going to plug in 4 for x, so 4. Oh, it's a negative 4, isn't it? Ooh, some of you must be yelling at me. Times negative 4 plus 3y equals 2. Negative 16 plus 3y equals 2. I'm going to add 16. I get 3y equals 18. And I get y equals 6. So my coordinate is negative 4, 6. So the reality is, this is not what it looks like. The reality is, it's going to be somewhere 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. I don't know what the lines look like, but I know they're going to cross through here. Negative 4, 6. You don't need to graph it. I'm just showing you. Don't worry about that. And that's it. That means that these two linear equations share the same points. Negative 4 and 6. We eliminated the y, and that allowed us to focus on the x's. All right, that's number 1. So let's do number 2. Now, I'm focusing my attention right here. I can't add them. So realize that if they have the same sign, then just subtract them. If it was negative 9x and negative 9x, you'd still subtract them. That would be like that and that. You'd add them together and you get no 9x. So I'm going to subtract these. So what is 9x? And again, what are we doing here? We're eliminating one of these variables. We'll be stuck with one variable. In this case, it'll be the y. We'll solve for y. That will tell us what y these two linear equations have in common. And then we'll find the x. So let's subtract. 9x minus 9x, 0. So why don't even write it? Don't even write it. Negative 8y minus, I'm going to subtract 2y. I have a negative 8y. I'm not going to add 2y. I'm going to subtract. So it's going to give me negative 10y. And then, and sometimes I like to do this. I like to say this is a plus, that's a minus, that's a minus, that's a plus. That's what I do sometimes. That helps me. And then, anyway, 7 plus 13 is 20. Divide by negative 10. Divide by negative 10. You get y equals negative 2. Am I done? No! I'm going to plug it in to either this equation or this equation. It does not matter. Because they share the same point. And the whole point is that I want to find the same point that works for both of these equations. So let's take the first equation, copy, paste, and I'm going to get 9x minus 8 times negative 2 equals 7. 9x, negative 8 times negative 2 is a positive 16 equals 7. I'm going to subtract 16. I'm going to subtract 16. And I get 9x equals negative 9. I'm going to divide by 9. Divide by 9. I get x equals negative 1. I'm now going to write the coordinate as negative 1, negative 2. If I don't believe that that works, it should work with this one. It should work with both equations. If it does not work with both equations, I've done something wrong. And it happens. Do wrong things all the time. So check your work, which I did not do. But you can. Moving on. Anything jump out at you? The 7 y's. So they have the same sign. Let's subtract them. Here we go. Now, again, this is how I do it. I am going to make this, actually, let me do this. Blue, I'm going to subtract them. Now I'm going to change some things here. I'm going to make that a plus. I'm going to make that a negative. I'm going to make this a negative. I'm going to make this a negative. So I've got negative 4x plus a negative 2x, and that gives me negative 6x. I've got a 7y. I'm going to add to it a negative 7y. They cross out. I've got 11 minus 47. That is a negative 36. Divided by negative 6, and I get x equals 6. What am I going to do? I'm going to plug it into an equation. Paste. Negative 4 times 6 plus 7y equals 11. Negative 24 plus 7y equals 11. Plus 24 plus 24. I get 7y equals 35 divided by 7. I get y equals 5. I then come over here. I say 6, 5. Boom. I'm not sure. Plug it in there and see if it works. Folks, that's it. Last one. Again, I'm looking for the one coordinate that will work for here and here. The best way to do that is to get rid of one of these variables. Ooh, I've got 9x and 9x. But, and this, I messed this up before, I don't have this in ax plus by equals c form here. Here it's ax and then it's on the other side. I can't do that. So what am I going to do? I'm going to subtract 4y. Subtract 4y, and I'm going to get 9x minus 4y equals 42. Now I can take this, put it here. I can even move it. Look how good that is. And now I'm combining. I've got two equations that look alike. They've got the ax and the by on one side, and then the c on the other. So I've got a 9x and a 9x. See it? They're both the same sign. So I'm just going to subtract. When they're the same sign, you subtract. Negative 9. What I'm going to do, I'm going to change it to plus a negative, and a positive. Go, 9x and 9x. Bang, 9x minus 9x. Negative 4y, I'm going to add to it a negative 8y. This is going to give me a negative 12y. And then 42 plus 30 is 72. Divide by negative 12, divide by negative 12. And I get y equals negative 6. I'm then going to plug it back into this guy right over here. Ooh, I have so much room over here. Ooh. So 9x plus 8 times negative 6 equals negative 30. 9x minus 48 equals negative 30. Add 48, and I get 9x equals 18. Divide by 9, you get x equals 2. 2, negative 6. Folks, that's your point. You don't know if it's true? Plug it back in, and it should work. Folks, that's it. Hope you had a great Wednesday. I'll see you tomorrow. Have a great evening.